Hello and welcome to the Screencast, where we will find missing angles in applied contexts. So our first example states, the peak of a mountain is 400 meters higher than the local airstrip. A plane takes off on a runway in the direction of the mountain at an angle that is kept constant until the peak has been cleared. The plane is at a horizontal distance of 2,025 meters to a point directly below the mountain peak when it takes off. If the pilot wants to clear the mountain by 50 meters, what should be the angle of takeoff? Give both an exact and approximate answer in degrees. Take a moment here to think about and draw the situation and try to set up a relevant trig equation to answer the question. Okay, so we have a local airstrip and the peak of the mountain is 400 meters higher than that. The plane is a horizontal distance of 2,025 meters to a point directly below the peak. So if we're calling this the peak, then directly below the peak would be this point here where we have a right angle, and then this point on the left would be the plane when it starts takeoff. All right, and the pilot actually wants to clear the mountain by 50 meters. So this is probably not to scale, but we have to keep in mind there's an extra 50 meters there. So the plane is going to take off and approximately hit that point there. So this is probably not to scale, but it gives us an idea of the situation. So when we think about the angle of takeoff, that's going to be this angle down here. I'll call it alpha. And in relation to alpha, we have the opposite side, which is actually going to be 450 meters, the 400 plus the 50, and then the adjacent side, 2,025. So that means we're going to use a tangent function, right? We know that the tangent of alpha would equal 450 meters, because we have to add that extra 50 meters of clearance, divided by 2,025 meters, and we can use the arctan function, the inverse, so the 450 divided by 2025 becomes the input, and the angle alpha is our output. So this would be the exact answer for the angle at which the plane needs to take off. And using a computational device in degree mode, we would get an angle of approximately 12.5288 degrees. So I don't think my picture's to scale at all, but it gave us an idea of the situation. Let's look at one more applied context. A boat uses 30 meters of rope to drop anchor in a location of a lake known to be 19 meters deep. What angle in degrees does the rope make with the bottom of the lake? Again, I would pause the video, try to draw the situation, and set up the relative trigonometric equation to represent the situation. Okay, so I'm going to let this point represent the boat. We know that the lake is 19 meters deep in this location, but it took 30 meters to drop anchor. So my picture kind of looks like the last one, probably still not to scale, right? So here's the bottom of the lake. Here's the anchor, right? And due to a current or waves in the lake, the boat's drifting a little bit. So there's 30 meters of rope, even though the lake is only 19 meters deep. So if we're trying to find the angle the rope makes with the bottom of the lake, then we're looking for this angle down here. I'll call that alpha again. In relation to alpha, we now have the opposite side and the hypotenuse. So we're going to use a sine function. The sine of alpha would equal 19 over 30. And we would use the inverse sine function of 19 over 30 to find alpha. This would be our exact answer. And then using a computational device that is in degree mode, we would find that that angle that the rope makes with the bottom of the lake is approximately 39.296 degrees.